title of 3.2 is the remainder theorem. Now, before we get to the details of the remainder theorem, we need to remind ourselves of how to do some division. So I'm going to start off with long division just of numbers, and we'll link that to the long division of polynomials, and then we'll worry about what the remainder theorem and factor theorem and things like that are. So to test your old school math skills, I haven't taught young enough grades to even know where they teach you to do long division, but I'm going to divide 426 divided by 15. So I look and I say, how many times does 15 go into 42? And I say 2 times, since it didn't go into 4. Sorry, I should have mentioned that. But 2 times 15 is 30. 42 minus 30 is 12. And 15 doesn't go into 12, so I bring down this 6, and I say, how many times does 15 go into 126? That one you might even need to think about for a minute, but the answer is 8, because 8 times 15 is 120. So when I subtract 126 minus 120, I get an answer of 6. Now, 15 doesn't go into 6, and so this is what we call the remainder. So we have ourselves a remainder of 6. So there are a couple of just vocabulary terms for us here, so I'll label some of these. So we have something called a dividend, and that was the big number we started with, 426. The divisor is what we're dividing it by, so in this question that's 15. The quotient is what do we get on the top there, so the answer to that is 28. And in this case we had a remainder, and the remainder is 6. If we didn't have a remainder, what we'd have is the number that was a factor of our dividend. So our quotient times our divisor equals our dividend if we have a remainder of 0. If not, we can write down a division statement still, and it looks like this. The simplest statement is this, that our divisor multiplied by our quotient, so 15 times 28, add 6, and you end up with your dividend of 426. So that's one way of writing the division statement for this one. The other version of that basically divides everything by 15. In a way, it kind of restates the question to say, well, what's 426 divided by 15? So 426 over 15 equals 28 plus 6 over 15. So if you try either one of those statements on your calculator, you can confirm that they actually do come up with true results. So the reason why I did that long division is unfortunately not that that's what I get to test you on, because I'd love to have some of those on my exams, but we're going to be doing questions more like this, where we're taking a polynomial dividend, 2x squared plus 4x plus 7, dividing it by a binomial divisor, x plus 5. Now, this one takes a little bit of practice, but we still are kind of following the same steps to say, what times x equals 2x squared? I say, well, 2x. 2x times x equals 2x squared. 2x times 5 equals plus 10x. And so I'm going to do the same type of thing I did before, subtract this from the top. So 2x squared minus 2x squared cancels them out. 4x minus 10x is negative 6x. I bring down the plus 7. Looks a lot like long division with numbers. I say, what do I need to multiply x by to get negative 6x? I need a minus 6. Negative 6 times x is negative 6x. Negative 6 times 5 is minus 30. I subtract them, and I get the x's cancel. 7 minus negative 30 is 37. So I do have a remainder once again. So all the parts are labeled the same. We once again can call the dividend, the big thing that we started with, 2x squared plus 4x plus 7. The divisor is x plus 5. The quotient, 2x minus 6, and the remainder, 37. So the last thing to do here is we could be asked for divisions, or our division statements. One of these is here, just to say that x plus 5 times 2x minus 6. If you FOILed all that out, you would still have to add 37 to get the polynomial there, 2x squared plus 4x plus 7. The second division statement, which is often the one they ask for, you basically have divided everything by x plus 5 from the previous statement, so you have the big polynomial dividend divided by the divisor equals the quotient plus the remainder over x plus 5. So that would be often what you're asked for in the section 3.2.